Okay, so this is the part of the semester that gets a little bit more trickier. Okay, once upon a time, when this was part under a different lecturer, big data, basically, they were supposed to learn how to do coding, and then eventually decided not to do it. And then when I took over the course last year, I wanted to talk about big data in a way that makes sense for people who don't actually know how to do any programming. Okay. This week, actually, Sandy is on traveling for business. Okay, so he's actually in Singapore. He will pre-record a tutorial and he will post it online for you guys to look at later. Okay, but essentially, I think a lot of the work that he will be doing mainly is to support you guys when it comes to your presentations or when it comes to your assignments. So today's lecture, we are actually going to be talking a little bit about what is natural language processing, okay, and how do we utilize NLP in current technology, and how do we apply it, and what are some implications of NLP technology, okay. This is important especially for the field of science communication, mainly because in science communication, as far as practice is concerned, or us doing the job of science communication, a lot of times what we're dealing with is words, okay? And this is important, all right? In big data, there are two types of data that you have. One is numerical, and one is, in a sense, language-based, okay? So what this means is that there is the statistical side, which is basically where we use a lot of numbers, okay? But in science communication, what we're more concerned about is the use of words, the use of phrases, the use of paragraphs, and the general processing of language, okay? Before I continue further with my lecture, I'd like everybody to log in your attendance on Spectrum if you haven't done it already. Okay? Anyone logging your attendance already? Sure. Yeah, because I always say this and everyone says yes, and some of them forget. All right. So what is NLP? Now, natural language processing is basically a version or a very early version of AI, okay, and computational linguistics that tries to look at how computers interact with the human language. Okay, we have to understand a few different things. Now, it was not easy for us to get to this point. We had been using computers for at least about 100 years. Okay, the first computers were very, very big calculators. Okay, they were basically very big calculators. They were essentially used for encryption. They were used for various different things. If you watch movies like The Imitation Game, or if you see other movies that relate to the early parts of the birth of the computer, basically you realize that computers in the early years were used mainly to create spreadsheets or Excel sheets, okay, that we know of today. All right, they were used to make sense of data. They were used to basically do computation or calculations. It was only later on that we started to talk about how can we utilize computers to process our words, okay? And the reason why is because words are very different from numbers, okay? Numbers are something quite universal. No matter what language you speak in, normally everyone uses the same numerical system, okay? Normally, everyone uses the same numerical system. But when it comes to words, it gets very tricky. On the one hand, words are not standardized, okay? When we think about languages, right, we realize that different languages exist in different parts of the world. Different languages get changed and also become modified based on the people that are using it. find different ways, okay, to make it sound interesting, to make it sound different. And that creates a problem when we talk about computing our natural languages. So this is where, our current processing power has enabled us to actually run a lot of these language processing. In the past, we were running on very, very small processors. Nowadays, with our processing power, we are actually able to do a lot more with the languages that we have. Okay, in other words, we have taken the time as as programmers to basically classify and basically map out the entire English text or the entire Chinese text or whatever it was. And this kind of allows us to do more complex, um, in a sense, processing of all of these different language data. Okay. Now, this is important, yeah, because this is basically the beginnings of what we know today as AI. Okay. The Chat GPT that you use today or the Google Gemini that you use today basically started here. All right. Basically, it started here. It basically started with us being able to use text and be able to respond to text. Okay. So this is how it began. And through this process, eventually we actually are able to get computers to predict what kind of response is appropriate, what kind of tone is appropriate, how are they supposed to deal with information, how do they summarize, how do they translate, how do they react. Okay? So why is it important for us to think about NLP in science communication? On the one hand, we notice that it is not really possible for science communicators to understand all the science all the time. Okay? A science communicator is basically supposed to be able to translate science into everyday language. Is able to understand what's happening in both realms, both the scientific and also the public or the social, and then ultimately be able to play the role of mediating between these two groups. But then there is a lot of scientific output that gets generated all the time. Okay, the estimation is that there are about 3 million papers that are being written every year or being published every year. Okay, and there's no real way for people to be able to really keep up with all of these trends. Okay, what this means is that there is an opportunity here for us to utilize um, artificial intelligence or utilize different types of NLP modules in order for us to help us to digest all of this information and be able to understand what's happening very quickly. On the other hand, science communicators are also expected to be able to engage with the public and drive the science narratives in the various different channels. Okay, so if you want to play a more effective role in engaging the public, it means that you need to be able to interface with thousands, hundreds of thousands, millions of people all the time. Okay, so imagine yourself as, say, a social media manager for a research institute or for a university. Okay, your job is basically to monitor the newsfeed, to monitor your mentions, and you need to be able to engage with people, and you need to be able to respond to crises, and be able to understand what's happening and feed back to the management. So there is a lot of aspects in this case where information overload or your ability to crunch all of this information um, needs to be very sensitive. Okay, which means to say that there is a big need for automation. It's not really possible for one person to handle all of this. Okay, and it's not really possible as well for universities or for other organizations to hire an army of social media managers, right? So what they normally do is that they get one person to be in charge of it, but then they will give that particular person all the tools that is required for them to be able to handle this large scale of data. So normally for me, when I was managing corporate comms, or rather when I was an executive for corporate comms, um, I had a few tools that were given to me or that we were subscribing to that allowed me to understand what was going on. Okay, so I would have different subscriptions to different types of services that allowed me to understand where the company was being mentioned, where the company was uh, perhaps being spoken of badly, or different places where maybe maybe certain things that were happening that need to be alerted to our um, management. Okay, so if not for these tools, it's very difficult for me as one person to be able to keep up to date about what's happening in the entire internet. Okay, I cannot be setting reminders to ask myself to keep searching for the name of my company every hour. All right, so I need to set up alerts. I need to set up different services in order for me to keep up to date with what's happening. So manual analysis is really not possible. It's also not very practical as well. So what it means is that a lot of times for communications professionals, you're really only as good as your tools are. So what are some of these NLP techniques that we know of today? So these are some of the aspects of natural language processing that we actually have. Okay, there is this aspect of this. Some of them are not very difficult to understand. For example, name entity recognition. So basically, over here, you allow you basically have a list of names that you are picking up. Okay, so imagine like you have a list of words, okay, that you want to search for every 2 minutes. Okay, you have a list of words that you want to search for every 2 minutes. And this could be, so imagine you're working for University Malaya, right? Okay. And if you're a social media manager for University Malaya, your job is to make sure that our Vice Chancellor understands all the potential problems that can cause by whoever who works here. Okay. So what is the way for us to do this? Number one is you need to make sure that you're searching for what's going on, right? One way to do that, number one, is to search for the name of the university itself. Okay, so that's the first name entity. Okay, the second thing is to search for your own name, the vice chancellor's name. Okay, because normally when people scroll the university, they scroll the vice chancellor. Okay, so you put the vice chancellor's name as a main entity as well. Okay, then you put in other members of the management. You might want to put in the names of the various deans. If you have the time, you put in the names of all of the lecturers of University Malaya into your lecturers. Okay? Which means to say, anytime any of your lecturers get into trouble, okay, and they are being named in a story together with the university, you will pick it up. Okay? So it's not just about trouble, it's also about recognition. So anytime that any story comes along, you want to know that it's out there. Okay, so name entity recognition helps you to be able to build this together. Now, this is not a very new technology. Okay, this has been around for a long time. So this is basically the same process that you go through when you are using a search engine. Okay, so like for example, when I was a PhD student, what I would do is that on Google Scholar, I would set up an alert. Okay, so I would have basically a search string that I would have, and then basically any time that a paper comes out related to my area, Google would send it directly to my email. Okay, so obviously I was doing my PhD. Okay, so I was supposed to be, I need to understand everything that's happening within my PhD, right? But my worry is while I'm doing my research during that 2 or 3 years, some other people will publish something in my area and maybe disprove what I'm saying or do exactly the same thing that I'm doing. Okay, that's my biggest fear. So I need to set up this alert so that every time that anything similar to what I do comes out, I will know about it. Okay. So it's the same technique that we're talking about over here, okay, where you have names and different types of verbs, also different types of nouns that you can actually extract and actually utilize, okay. Now, the next one is called topic modeling, okay. Topic modeling actually looks at the way words co-occur, okay, the way words co-occur. So which means to say, how often do certain words appear together? Okay, how often do certain words appear together? All right. This is similar to CF-IDF. So what is CF-IDF? CF-IDF is officially term frequency over impression in documents frequency or something of that nature. Give me 1 second here. This is what happens when you learn things a long time ago and then you forget. Term frequency inverse document frequency. Okay. So basically, what it does is that you measure how relevant a word is to a specific document within a broader collective corpus. So what you do here is that you basically look at how often a word occurs in that document, and then how often that word occurs across a series of documents. Okay. So TF-IDF is actually a type of analysis maybe 6 or 7 years ago, was sort of in my area of research, was very commonly used, okay, to basically determine how important certain words are within a particular corpus. So for example, if I'm looking at research papers and I want to understand how important the term science communication is, okay, against all other journals in the field of communication. That's how I would do that kind of study, okay. Aside from that, there's also document embeddings. These are ways for us to determine how do we identify what are the dominant themes in these news articles, okay. So what you're trying to do here is that you're trying to look at different terms and you're trying to determine what is the dominant term in that particular document, okay. So this is a way for us to model the topics in a way that is not supervised, okay. Now, I'm not going to talk about the second, column, okay. The second column is basically a list of the algorithms, which, to be quite frank, you don't need to remember, okay. But it's there for your reference in case you ever need it, okay. It's just there for you to refer to in case you ever need it. You don't need to remember this. But the thing is that what you need to remember is the NLP technique and how do you actually use it and what is it actually used for, okay. That's the more important part. I think I did mention about sentiment analysis before. Sentiment analysis is where we try to compare the words or the sentences that are being used against specific types of attitudes. Okay. So what it does over here is that it will look at a particular passage and it will tell you if that particular passage is being positive or negative towards a particular issue. Okay. The challenging thing about sentiment analysis is much more better now, but in the past we struggle when people try to use sarcasm or when people try to joke around a little bit with it. Okay, because computers don't really understand humor. Okay. So what happens then is that the computer might actually mistake somebody's sarcasm as misunderstanding. All right. So sentiment analysis is how we can actually track attitudes and see how acceptable our people are. Okay. But sentiment analysis also struggles, especially when people put comments, but they put very vague comments or they put comments that are not well expressed. Okay. So sometimes when you put just a single word, or sometimes when you put a single abbreviation, it's very difficult for the algorithm to be able to tell. I think at this point, emoticons are quite okay because they have specific sentiments attached to them. Okay, but then when it comes to things like SMH lah or whatever lah, many people might actually struggle to actually understand. Particularly if you're not writing in English. Okay, so for example, in Malaysia, when you're doing social media management in Malaysia, a lot of people write in Malay. Okay, so especially when you're managing brands in Malaysia, right, and especially you're dealing with brands that are maybe a little bit more lower end in the spectrum, you have all kinds of languages that you need to deal with. Okay, and Malay is one of the biggest languages in Malaysia, obviously. So when you're dealing with Malay, right, you realize that there's a lot of things that people write or that people type that you don't really see anywhere else. Okay, so it can be a bit challenging to be able to process all of this. Okay, I don't read Chinese, so I don't know what is the story with Chinese. What I do understand is that maybe when people write in Chinese, maybe they don't write the full form all the time. Okay, and that's something that I've come to learn when I travel in China, is that people don't really use the full sentence, or they have very, very quick abbreviations of very long words. Okay, so I think that is something that, sometimes the algorithm might struggle with. Okay, another one is text summarization. So this one, what it does is basically it will study articles or press releases, and then it will basically generate these kind of like summarizations. Okay, so what it does over here, so there are a few algorithms that does this. One of the famous ones that people use is TLDR. Okay, what is TLDR? TLDR means too long didn't read. Okay, so sometimes when an article is too long, you will call it TLDR. Okay, so basically there is a website out there where you can actually throw documents into TLDR and it will help you summarize what a document actually says. Okay. Lastly is semantic searches. So this one is actually quite, I've seen it being used before because in my other life, basically what I do is related to technology management. And one thing that we do is that we want to understand how close our patents or our inventions are to other people. Okay, so the easiest way to do this is that you throw the entire document into semantic search. Okay, and then that document will be searched in its entirety against other types of literature. Okay, it actually is much more sensitive compared to just keyword searching. Okay, because you are utilizing the entirety of the document, and it actually improves the discovery of the searches that you actually get. So it's not the same as keyword searching. Okay, semantic searches. And it's also a lot more sensitive. All right. So these are just some of the various different techniques I talked about earlier. I always forget to do this. Okay, which means to say that I put a paper on the front and I talked about it, but then I realized that I haven't slides as well. So with name entity recognition, okay, these are the various toolkits that you can actually use. And then the key thing over here is that whenever we set up our algorithm, we make sure that the algorithm basically helps to generate the right metadata for these particular researchers. Okay, so in this case, right, whenever we write a paper, normally they will have a lot of different data that goes into that paper. Who we write with, okay, who are our co-authors, what university we come from, what is our email, all of those different information needs to be actually sorted out accordingly. So whenever we submit a paper into a journal, what happens is that there's a long list of things that we need to fill out before that paper actually gets processed. What happens then is that information becomes the metadata for this particular article. Okay, metadata means that even within the PDF itself, okay, all of this data will be stored in the PDF. So basically, whenever you scan the PDF, all of this information will be properly set up in a table. Okay, and this is important, especially for the issue of indexing. Okay, um, indexing is important because indexing is the process in which all of this information is actually being organized, okay, across all the different journal articles that are out there, so that it is actually going to be able to be searched effectively. Okay, so this is how you prepare for name entity recognition. Okay, first of all, you need to make sure that you have the right keyword set up, and then also you need to make sure that you tag the right information for that particular document. Okay. I've already talked about topic modeling to some degree. The key thing over here is that if you do topic modeling the right way, okay, you can actually understand the changing patterns in a particular area. Okay, so one thing I did for my research in the past was that we actually did a version of topic modeling, but then we did it across different years. Okay, so the way we do it is to actually try to understand what is being discussed or what is the topics that are or what are the words that are being used in a particular time for this particular topic. Okay, so for example, let's talk about, say, COVID vaccine, right? So if you take slices of data, okay, which means to say that, for example, I take a slice of data from 2018, and I take a slice of data from 2021, and another slice of data 2024, another slice of data 2026, I would see different landscapes in the discussion, okay? And this is actually quite interesting, especially when you discuss about, how does these landscapes change over time? What do journalists actually pay attention to? How are these information being framed? Okay, so this type of topic modeling algorithm can be quite useful for research, and especially in trying to discover patterns in the reporting process, and also to discover different types of trends that are happening. Okay. All right. We've also used sentiment analysis for various different types of projects before. A lot of these, okay, I'm just going to stop here for a short while. Basically, a lot of these algorithms, right, are not too difficult to learn. Okay, so bear with me, yeah. All right, so there are two major languages when we talk about doing big data analysis. Okay, R, okay, R, the letter R, okay, the letter R, and the second one is Python, Python. Okay, R and Python. What's the difference? R is a very basic. Okay, they're both very basic. Okay, they're both very basic. You actually need to utilize codes for these two different areas. Okay, it's not so straightforward to learn. But the difference is, for R, you have R Studio. Okay, so R Studio is a lot more simpler to understand. Okay, because R Studio has different libraries that you can actually use to carry out the algorithms that you want to actually utilize. Okay, so in other words, with R Studio, life is a lot more simpler. Okay, with R Studio, life is a lot more simpler. You don't actually have to spend too much time and effort to learn the coding in order to make things work. The difference is with Python, the good thing about Python is that Python, you can actually take the data and get it posted onto the internet automatically, okay? Because Python actually allows you to feed your data online, okay, or in an automated way, all right? It is not the same as R, okay? R is mainly just utilized for localized analysis, okay, which means to say you just do it for yourself, all right? You're not making a portal out of it, or you're not turning it into live data per se, okay? which is the difference between the two. Now, I say you need to learn coding. Nowadays with AI, it's not that hard to actually learn coding because AI can actually do it for you. Okay, so your ChatGPT, your Gemini can essentially help you to code the necessary, put in the necessary code into these very different programming languages in order to actually get you what you need. Okay, the key thing over here, okay, it's not about the programming. The key thing over here is understanding what output you actually want. Okay, and this is the big crux of your assignment. It's about how can you take information that's out there and turn it into information that's useful for other people. Okay, that is the difficult part, all right? Because you want to create data or create information that people can actually use, that people actually find valuable, that people can actually pay you money for it. Okay, that's the hard part. The programming part, right? Worst come to worst, can pay somebody to do it. Okay, worst come to worst, can pay somebody to do it. But the process itself, the intention, how does it fit in the market, all of these sort of things is more, that one is much more harder to actually do, okay? So, it's one thing to learn about sentiment analysis. The hard part is how do you actually utilize sentiment analysis, okay? Now, in the communications era, okay, or in the communication sector, normally sentiment analysis gives us a bird's eye view of how people are reacting to a particular situation. Okay, so especially in situations such as crisis communication. Okay, when you talk about crisis communication, if you have an automated way in order to score the sentiment of different people's reactions, that means that you have a way of determining if this is about to explode or you still have time to figure out your game plan. Okay, so there are different uses for it, but normally it helps you take the temperature of what's happening and how are you going to react to it. Okay, but nonetheless, normally for people who are involved in this kind of research, you realize it's very standalone. You need to say that you just do this one time and then you don't follow up. Okay. But if you want to use this frequently, you normally have to have something which is live and something that people are looking at all the time. Okay, I've talked about this already, things of TLDR. Semantic search, I think I mentioned it already. Okay. Yeah, so normally for semantic search, like I said, it's about a lot of dense data, we're searching for specific content. Okay. Oh, going really fast. Any questions so far? Any questions so far? I haven't finished yet. I'm just asking if there's any questions so far. Anything I'm not sure about. Okay, so one thing I want to mention over here is that when we think about the way we use AI today, right? Okay, we realize that actually a lot of times our process of dealing with AI, okay, is actually very much basically you're talking to a semantic system. Okay, the way you use AI today is actually very much like the way you use it. You realize that actually, in order to improve the algorithm, you actually have to spend time talking to it. Correct? Okay. You also need to be very detail oriented. Don't just take it for what it says. Okay. And you also have to be very clear about the kind of mistakes that it's going to make. Okay. So AI is a way for us to, it is sort of like an example of this, all right? Basically, we realize that whenever we use AI, our experience actually requires us to keep refining our we need to keep refining our I think I cannot think of the word. Our prompts. Okay, we need to keep refining our prompts. The one way for us to keep refining our prompts is to give it more information. Okay, one way is also to give it a lot more background. Like the way I would use it nowadays is that I normally upload documents together with my prompt. Okay, just to give it more background. Okay, and you realize that the more you train the AI, right, the better it works. But at the same time, your worry is what about the information that's giving it? Is it necessarily where is it going to be stored? How is it going to be used? Now, what some people actually do. So, like for example, I believe that University of Malaysia is releasing its own AI called Aura. Have you guys heard of Aura? Yeah. Apparently, is actually coming out with their own AI to be used in Spectrum. Okay. I don't think it's been launched yet. All right. I don't know how smart it really is. Okay. So you probably would have graduated before you actually get it. All right. Judging from how quickly things work. But that is one thing that people are doing. Is that instead of relying on Google, instead of relying on OpenAI, they build their own LLM, okay, in order to ensure that the data is remaining inside their own company or inside their own institutions. Nonetheless, it does not prevent other people from using it, okay? So let's say some people have access to it, they can learn a lot from it as well, all right? So that's the first thing, okay? How well do you train it? How well do you build it? And those kind of questions. But right now, my team is actually building AI engine. But the thing is that when we're building it, right, we're very clear to say that we need to be able to actually categorize our information separately, which means that different types of users are supposed to use different aspects of the AI. Okay, that's more for our own research, all right? But this actually allows us a lot of potential uses for us to actually think about. Okay, so when you think about building your own app, right, you also need to think about what else is there for you to use, or what other ways can you actually build out your application. Now, the programming part is not the difficult part, okay, because I think that a lot of people are quite capable of building different types of programs. It is more the hardware part, or it's more the other resources that you need to consider. So for us, actually, you can get a lot of web services from different companies, okay? So like, for example, when you think about it, right, in order to build a semantic search engine, you actually need a lot of processing power, okay? You actually realize you utilize a lot of processing power. So what people would normally do is that I will build my algorithm, okay, but I will power it using web services. So the most, in the Western world, the most popular web service is actually from Amazon, okay? So Amazon Web Services sells credits for us to actually build these apps and actually get powered by them. They also sell storage. They also sell all kinds of different services that allows all of these different products to um, actually be realized. In China, this is taken up by either Tencent, I believe, Alibaba also has web services, Huawei also has web services. Okay, so different companies basically owns their server farms and different hardware, and these technologies help to basically run or basically power a lot of these algorithms that are out there. Okay, so if you understand things like, like WeChat has a lot of mini apps, right? Okay, WeChat has a lot of mini apps, right? A lot of these mini apps basically subscribe to the different types of services under Tencent. Okay, and everything kind of works together. All right. So being part of the ecosystem means that you all speak the same language, you all use the same currency, you all use the same data resources. Okay. So that actually helps the entire ecosystem to grow together in that sense. Okay, which is why the data part is very important. Now, the challenge comes when you're thinking about scaling overseas. Okay, the challenge comes when, like, if I want to move into the Thai industry, I want to move into the Thai market. Um, what about the data? Can I pull the data out of Thailand? Okay, can I process the data in China? Then can I send it back to Thailand? The answer is normally is no. Okay. So what is it? What does it actually mean? Normally, what it means is that we need to keep the data where it is. Okay, but perhaps the processing power is going to come from somewhere else. Okay, and that's about it. So we may not necessarily move the data out of the country. Okay, but the data can be processed and then sent back without any of the personal data being utilized. Okay, so that is normally the process, which is not easy. Okay, but then sometimes we realize that people are willing to do it with the right legal cover. Okay, so that is normally the story. All right, I've been talking for about 45 minutes, which is normally when I take a break. Okay, so shall we take a 10-minute break and then come back? Okay. Okay. Let's continue. So I'm just gonna recap a little bit because I think that what is a couple of questions, but I just want to make sure everyone's clear. By the way, right? How many of you are doing a P1 this semester? The proposal presentations are third and fourth, right? Fourth and fifth. Okay, fourth and fifth, right? Do you know what time is the presentation? Okay, so both of you will start after them, huh? All right. So for those of you who are in P1, okay, I understand that they are doing the symposium or listening to the presentation at speed. Sorry, 2 weeks time. Okay. So that might make this a bit challenging for us to do presentations on the 4th of June. Okay. Would it be possible? Okay, so this is one suggestion, all right? One suggestion. So either, okay, remove the presentation, okay, and then we can do a class on the 4th of June instead, all right? Which means to say those people who need to present on the 4th of June, okay, you don't necessarily have to be in class in that day because it will be pre-recorded. You get my point? Okay? Because my worry is they're not going to take into account who is having class what time. Because I don't think they thought about it. Okay? I don't think they thought. It's being recorded, but then you don't post it anywhere, okay? I don't think they thought about this class, okay? So my suggestion is presentations, we could maybe move it to week. You guys prefer 13 or 14? 13 is better. Okay. So remove presentation to week 13. And then the second big data modeling class, we have it next on the 4th of June instead. Okay. It gives you 1 extra week to prepare your presentation. Okay. And then it means to say that those people who have to present their proposal don't actually have to be here physically, or they can come after they present the proposal. Okay? Because I understand proposal presentation may not take that long. All right? But my worry is a lot of people will be in and out. And normally, if the presentation is later, you will not attend the class before that and then disappear for the presentation, right? Okay, you normally just stay out and then you make the presentation on your own and you help. Okay, so is that possible? Is that okay? All right, so presentations, I will move it to week 13, okay? And then the 4th of June, we will do lecture 8. And then we can keep it on our way. Everyone clear? All right. And then the final week is the same. We will do the course summary. Now, okay, we're not affected by our Muharram. Our Muharram is another public holiday. Okay, but our Muharram is on a Wednesday, not Thursday, so we're not affected by it. Okay, yeah, that's fine. Okay, everyone clear? All right. So just to come back to the presentation. So the first part of the presentation, which we had a few weeks ago, was to talk about the concept, right? To talk about the wireframe, remember? Okay. So everybody did a good job. Okay, generally, I haven't released the results yet. Okay, I remember. Okay, this is a little bit crazy. Okay. But I'll release it. Okay. But the point is that the second presentation is not meant to be the same thing. Okay. Second presentation. Now, I want to make sure that everybody's clear, right? The data set that we use in this part, right, that's only the use case that is supposed to be part number one, which means to say that if you did choose to change your project from part one to part two, you can, okay? There's no need to stick with the same thing if you don't want to. So, what you need to do in the second part is basically to showcase how you're able to utilize a real data set, okay, and do some degree of analysis with the data set, okay. Now, you can actually utilize different types of tools in order for you to run this analysis, whether it is Google Looker Studio, Forest Studio, Power BI, different types of things. But you have to show that it makes sense for science communication, okay. Now, the different data sets are basically available through these type of sources, okay? Okay. So a lot of these data basically is available for use. There are also data sets available. So for those of you who have access to it, there are data sets from your home country as well that might require either a phone number or a WeChat ID or whatever it is in order to get access to it. Okay. Normally, these data sets are not that sensitive. It is possible to use these data sets, okay, especially from university data versus, okay. So like for example, there is public data available to different institutes, different universities. However, you need to log in, okay, and you need to provide some personal data for it. So normally, Chinese data is available for people with Chinese ID, okay, meaning not me. All right, so you can have access to it if you want to, but my point is that there is data everywhere, okay? In the same way that you might be able to find Indonesian data if you have Indonesian ID, okay? Malaysia, we don't have that many open data sources. You can try to look for it if you want, okay? But a lot of the open data sources are outside of Malaysia. So a lot of different things you can consider. If you can get access to these different data sets, you can do different types of analysis with these data sets, okay? But the key thing is that you're clear about what you're trying to be looking for, okay? What you're going to realize is that there are a lot more data and a lot more options out there. If you're not clear about what you're looking for, you may struggle to make up your mind, okay? And if you don't know what you want to analyze, that is going to be another problem, okay? So one way for you to narrow down your list of choices, okay, is to look at what other people consider to be meaningful analytics, all right? What do people consider to be meaningful analytics? So these are some of the things that you need to ask yourself before you start your second part of your assignment. Now, some of you maybe already finished, okay, that's fine. But then some of the advice I'm giving to you now, hopefully you can use it to help you find what you're currently done, what you're currently doing, or what you have already done. Okay? So that is the idea for this part of the assignment. The point of the presentation that I want to see, number one is data visualization, which means to say that you show that you had this idea, okay, This is the type of data I will use. This is how I will visualize the data. Okay, this is the kind of data that I will show. The next thing I want to see is interpretation. So which means to say, based on this data, what can we tell? What are we able to infer, or what can we summarize from this data? Okay. So when you present, okay, these are the three questions I want to hear. Number one, this is what I did. Number two, this is what I think it means. And number three, this is why it matters. Okay? So this is the few things that you need to basically explain in your presentation. Now, the people that presented in the first presentation don't have to present again in the second presentation. Okay? So you've already presented the first presentation, you don't have to present again in the second. Now, there was a question about the presentation, right? I think somewhere in your WhatsApp group or something. Yeah, I think I'll mention that I will actually address them. Can you just double check, yeah? Okay. Yeah, it's sorted. Presentation today. Okay, so presentation today, like I said earlier, is week 13. Okay, so week 13 is only the next presentation. Okay, so we provided some suggested tools. Okay, and then these are just the same presentation requirements as before. The order of presentation will be the other way around. Okay, from the first presentation. All right, so if you remember, in the first presentation, I already put up the list, right? Of who is going first, who is going last. We will flip it for the second presentation. Okay, so the person who went last during the first presentation will go first. Okay. Any other questions about presentation? Yeah. So next week there'll be no class. I'll be finishing up my marking, okay, for the test that happened a few weeks ago. All right, and then after that, I will try to post the result of the test as well as the first presentation in 2 weeks' time. Okay, and then after that, you guys can get ready for your presentation too. Then you'll be fully aware of what's the story for your continuous assessment. Okay, so all right, let's get back into it. Okay, so how do we utilize NLP in science communication, right? When we were, so for example, so I'm going to bring it, so my experience when I used most of this for science communication was when I was actually working in an NGO, okay? So when I was working for an NGO, our role was basically to help journalists prepare stories, okay, and to help them to get in touch with scientists. Okay, that was my job. I'm not kidding. Okay, I was interning in this NGO in Australia. Okay, it's known as the Australian Science Media Center. And basically, what we did, okay, was we put people in touch with scientists. We put journalists in touch with scientists, and we help them to build their stories, okay, and make sure that more science gets into their stories, okay. So the Australian Science Media Center is basically based off the British Science Media Center, okay, and then basically that's what I did for a few months. Now, how we utilize NLP. Basically because we spend the first part of the day trying to understand what science stories there are out there. Okay. Our job was two types. One is very reactive, okay, where we are just taking calls and trying to help people to find the right scientist for their story. The second one was more strategic. So the strategic one was where we were trying to understand what are the stories that are out there and how do we actually get this to journalists. Okay, so we would do these two types of services. Now, on the one hand, we maintain our own database. So my job was to make sure the database was up to date, make sure the database was useful, and make sure the database was sufficient for what we had. So every time we learn of a new scientist, or I would spend time tracking down scientists across Australia and putting the information into our system. Okay, the system is not very complicated. If you guys have heard of it before, um, there's this app by Microsoft called Microsoft Access. Okay, so basically you can create these databases from there. But then from there, that database actually allows us to run these algorithms inside the database in order to help us to find the right expert for these particular science communication systems. Okay. We also dealt with my future employer, okay, known as Meltwater News. That was another company that I worked for, okay. And this company basically does this thing called online media monitoring, okay. So online media monitoring utilizes a lot more NLP-driven type of algorithms. What it basically does is that it helps people understand what people are saying about them online. Okay, so we ran NLP algorithms not just for their brand awareness. We also ran algorithms to help them to understand what people are saying about them and also their competitors. Okay, so in a way, we were providing not just tracking tools, we were also helping them to gain intelligence. Okay, so that was our intention. And that was something I also did for a time. And then basically that helped me to understand the various different tools that come with NLP and also that came with these type of search engines. Now, a lot of these technologies were not very new at that time. Okay, it was actually quite a long time ago. But nowadays it's become a lot more complex. There's a lot more libraries, a lot more different ways for us to play around with it. And it's better, a lot more easier for us to actually play around with it as well. Okay? So there are different projects out there related to science communication that utilizes NLP. For one, there is altmetric.com. Okay? So altmetric.com basically is trying to change the way scientific research is being tracked or scientific research is being measured. Okay? So what it does is that it tracks how scientific research is being shared in the news and also in a sense, in sort of casual type of settings. So news and blogs, okay, which is not something that is commonly being discussed or not something that's commonly being looked into. So what it does is that it tries to identify scientific article mentioned in news. Normally, it does that by staring at journals that are being cited by these articles. So if let's say it cites an article that was published in the Lancet, or it was cites an article that was published in Nature or Science, something like that, and it will basically be able to pick it up from there. What it also does is that it classifies the sentiment or the thematic tone of that particular article as well. So in that sense, right, it actually helps people understand what is being reported, what do people think about it, okay, and how often does this coverage actually happen, okay? And based on that, it actually aggregates the coverage by discipline so that we can sort of tell what kind of disciplines are probably being discussed in more detail at one particular point in time. Okay, there's also what thing we realize is that science communication is getting more automated. Okay, So if your intention is to write about science after you finish or you graduate, you're going to be in for a good job. So we realize that a lot of writing these days are not being done by humans anymore. A lot of times communication is done automatically, okay? Which means to say that different types of algorithms are actually being utilized to summarize data into lay summaries, to transform information, to fine-tune the different types of data, okay, in order for it to be more accessible to other people. So it's very scary, okay, but it's also very true. But there is a way for you to work around this, okay? There is a way for you to work around this. On the one hand, okay, if you master these tools, then you can actually use them to help you to develop content, okay? That's one thing. The second thing is that if you are able to, if you're able to harness the tools, or if you're able to kind of work with the tools, you can help different organizations to reach their goals as well, okay? The one thing we realize is that AI is something that is embraced by society, okay, that people use for their daily life. It is currently being embraced by corporations, okay, private corporations that are trying to utilize any tools that is within their grasp in order to build value, okay, or they want to create more advantage by any means necessary, okay. So that is what private companies will do. But in the field of academia, in the field of government service, the use of AI is still a bit of a gray area, okay. So particularly dealing with science, okay, particularly dealing with sensitive information, particularly dealing with personal data, or dealing with government secrets, AI is not allowed to go in any way. Okay, so which means to say that for science communicators, really the safe spots for us to work in has a lot to do with government service, has a lot to do with traditional science and technology. If we want to think about doing science communication in private companies, you'll realize that it's very hard for you to justify your salary. Okay, it's not easy to justify your salary, even though we realize also that a lot of companies are getting more and more interested in doing it. Okay, so while there are companies that are keen to do it, they'll realize also that it's also cheaper for them to get AI to work on it as opposed to hiring a lot of people who do it. Okay, so that is something that we need to consider as well. However, AI can only take us so far. Okay, so I've seen both sides of the coin, right? I've seen situations whereby we no longer have human MCs. We no longer have human hosts or human presenters. Okay, because they just roll out the robot and basically the robot is the MC. Okay, which is okay. All right. And we realize that human presenters will have their own limitations. For example, I had to participate in a panel, and if the host was a robot, it would be able to translate directly into English, which the presenter couldn't. Okay, so that would be one problem that we need to solve. But at the end of the day, right, the human touch is still important for certain people. Okay, so for example, one thing we realize, and this is something that's quite interesting, is that there are more and more companies that are setting up their own interactive sort of facilities. Okay, so which means to say there are companies out there that in their headquarters they will set up their own little museum, or they will set up their own little interactive center for people to understand their products better and be able to sort of play around with the concepts or understand the science behind their products. Okay, so I keep seeing this everywhere. And a lot of times, the people who work there normally it's not fully automated. They always still have people to actually manage it because they need to take care of children, they need to take care of elderly people. So you cannot just automate everything. Okay. So what this means is that there's still jobs for science communicators out there. It's just that um, it's not as much as it used to be. Okay, it's not as much as it used to be. So having automation is not necessarily a bad thing. It just means that you have to find a way to kind of manage the process a little bit, or find a way to see how we can create a role for ourselves that will actually not be replaced. Another aspect is in public opinion monitoring. So it's just particularly true for ministries that deal with communications, Ministry of Health, for example, where they need to understand what people are saying, what people are thinking all the time. Okay. This is particularly true when it comes to managing communication risk. So in the 90s and the early 2000s, there was the theme around science communication was really about how do we combat pseudoscience, or how do we combat misinformation. All right. So the big project that is currently happening in Suzhou University right now is to talk about how can they build a way to detect and to combat misinformation online. Okay. But this particular project is very AI based or very IT based as well. Okay, because obviously when you're dealing with information at a very large scale, okay, you cannot help but utilize AI. So, but that one is actually being run by a professor in science communication, an FDS professor in science communication, and her project basically helps. It's actually looking into this in more detail, and it's actually being funded. There's a lot of money. Okay, but part of that process is to also determine what people are thinking and how people feel, okay, about a particular issue. And this type of analysis is important for us to understand different sort of feedbacks into what people are thinking, okay? And we can actually use it as a way for us to assess things like this, like hesitancy, people who are trying to decide whether or not they should take the vaccine, why they are not doing it, what are the reasons and things like that. And then also we can actually use topic modeling for us to help us to detect what are certain trends that are coming out. Okay. So this is important, especially for us to think like, okay, if let's say a particular misinformation trend is starting to emerge, what is the best way for us to address that particular trend? How can we reverse it? How can we find a way to mitigate it? Okay. So these are some of the aspects that we try to look into monitoring. So this is very government level. Okay. You can do it at an institutional level as well. Okay. If you're so keen, especially when you're dealing with a large population. Okay, it can be quite useful. But normally, this one is normally funded by government. Government wants to know what's happening. So that they can better govern or how they can better take care of the people. All right. Another thing that we see is this thing called the science policy interface. Okay. So in the UK, they use this policy evidence mapping tool. Okay, in order to link scientific literature to policy issues. All right. On the one hand, it is meant to actually help policymakers make more evidence-based decisions. They want to help policymakers understand what is the meaning behind what they're looking to do and try to help them to access scientific research in a way that they can understand it better. Okay, so this creates links between whatever policy that they are making and the science behind it, and this is particularly useful because obviously policymakers they come from all kinds of backgrounds. Okay. Outside of so for example, I think in most democratic countries, what we notice is that the people in politics are normally there because of their popularity. Okay, and they can be popular for many different reasons. They can be popular because of their personality. They can be popular because of their ability to talk sense. Okay, or they can be popular just because they are popular. Okay, so sometimes we cannot understand why. All right, so which means to say that the people who actually get voted in or become politicians have a very large variance in terms of their education background or their reliance on science and technology. Okay, you can have all kinds of different types of people who end up becoming leaders of your country. Not all your leaders will have PhDs. Okay, I wish that all our leaders have PhDs. Okay, we don't all have PhDs. All right. At the same time, we also understand that most of them may not necessarily understand the science as well as other people. So sometimes we need to really spend a lot of effort to educate and to help them to understand. And we need to expect it from them and go. Okay? So yes, a lot of politicians are a lot smarter than they look. Okay? A lot of politicians are also might not be as smart as they seem. Okay? So which means to say that this type of information needs to be made available to them and also need to be engaged with them in order for them to make decisions. All right. So this is a big deal in places like the US and the UK, okay, especially in European countries where you notice that there is a big gap between left and right, okay, which means to say that different politicians, they are very extreme views about different things. Okay, so what we are hoping for is that the science provides a neutral evidence base that everybody can agree on, right? That is the purpose of us thinking of this concept. There are also NLP-based learning assistants, okay, developed by IBM, for example, that helps with STEM education, okay? So what it does is that it helps answer questions. Okay, very straightforward. Basically, when you're dealing with children, you're building them an app in order for them to get the answers they need in the shortest way possible. Okay, rather than they have to constantly ask other people. Okay, it's a good initiative, but it also can create other problems. Okay, but the point of this is that it helps to tailor the content difficulty to the learner's level, so they're not constantly being bombarded with information that maybe they're not able to understand. Okay, so AI can help us to kind of adjust accordingly, because sometimes certain learners can learn faster, some learners can learn slower. So when they're struggling with certain things, the AI will help to coach them along with it. Okay, this is particularly true when it comes to especially helping people with learning disabilities. One thing we also notice nowadays is that our AI is being programmed to help more people with learning disabilities. So which means to say that if let's say somebody has autism, okay, perhaps the content will go slower. If let's say the person has a visual impairment, he cannot is blind or cannot see very well, okay, there will be either a braille function or there will be a function in which they will read out the information to them. Okay. If let's say that particular person has issues with hearing, okay, there will be other ways, maybe it comes with sign or something of that nature. I've even seen some places where they use certain functions for dyslexia. Okay, so dyslexia is basically where the words start to dance around and the letters start to change position and things like that. Okay, so there is a way for us to actually integrate that in today's kind of applications. All right, but the point is that these learning assistants are available for learners of all ages, and it kind of allows us to kind of ensure that we get the right things done. Okay, what are some of the implications? All right, now the present trend is that we are understanding is that we have a lot of multimodal NLPs. They're able to integrate text with audio, video, and video. For example, you can ask ChatGPT to generate images for you nowadays. You can ask it to write songs. Okay, you can ask it to build videos and things like that. Okay, so it is no longer a secret. Okay, large language models are very capable of having intelligent discussions with you. Okay, you can have very in-depth technical scientific dialogue with your LLMs. You can try it one of these days. Talk to an LLM while you're on your way to class and see how well it actually answers your questions. There are also ways for us to actually pair LLMs together with expert opinion, what we call human in the loop. Okay, so which means to say that not just allowing it to be completely automated, but you have a way for people to validate and to verify what the LLM is actually pushing out. Okay, so this is where you combine automation with expert oversight. So this comes to the question, okay, how can we ensure ethical use of NLP and classification? What are the limits of automation, communicating context and consent? Could NLP widen or narrow context? Okay, so these are just some discussion points for us to think about. I understand next week is going to be a break, and then everybody's going to be rushing for proposal presentation the week after. Okay, so I'm not going to stress everybody to add another tutorial for no reason. Okay, but Chen-Yi is going to be in touch with regards to what's going to be discussed for tutorial. Okay, after this. So for the time being, that's all I have for today. Okay, so thanks everyone for coming. We'll see each other again on the 4th of June. For those of you who are presenting a proposal, all the best. Okay. If you get me as your examiner, then really all the best. Okay. If you don't get me as your examiner, then it's fine. For my students, please be farewell. Please. Okay. Otherwise, thank you all for coming. I hope I'll see you guys on the 4th, if not the following week. Thank you.